Find that distance.
Easy, Mr. Fay. Challenging.
Chuck? 5. Okay. So 7 minus 3 gives you 4, right? We'll square that. Add to it. 5 minus 2 gives me 3. We'll square that. So we get 16. 16 plus 9, root 25, which Chuck is telling us is 5, right? Awesome. Okay. Well, then you're wrong. What if I ask you to find that distance? Now, how can I find that that's 5? Okay, now because it's a vertical line, right? You say count, but really what we're doing is we're taking the y value here minus that y value, right? Okay. Because you could use this formula. But when I subtract 3 and 3 as my x's, what's that give me? 0. Square that, you get 0. Here, if I subtract my y's, I get 5. If I square that, I get 25. But then I square root the 25, I get my 5, right? So why not just do the difference and get them that way, okay? What if I gave you, let's say, that point there, okay? If I take those, if I subtract the x's, what's 3 minus negative 1? 4. Square 4, you get 16. Take my 2 minus negative 1, you get 3. Square that, you get 9. 25 gives me 5, right? All of these points that I'm asking you to find are points that are similar to those blue points, right? Okay. What is that shape? That shape is a circle. Okay. So, and the reason that we're getting that is because what is the only thing that dictates a circle? What is the only component that is this a necessity for us to determine a circle? A radius, okay? And the distance formula generates that radius, right? Okay. Now the singular component in each one of those that was the same was that every one of those used the 0.32, right? Okay. So every one of those blue dots is an ordered pair. Okay. There should be an equation that every one of those blue dots satisfies. Okay? Kind of like if I have the line y equals mx plus b, right? That's a generic formula for any line like maybe 1/2 x, y equals 1/2 x plus 3. Okay? Every point then on that line, y equals 1/2 x plus 3, will make that equation true, or will satisfy that. Okay? And you guys remember going back to Algebra 1, if I were to give you a line, and it crosses the y-axis, and it also, you can determine the slope, can you give me the equation of that line? Okay, so we should be able to do that with any curve or line that we ever deal with. Okay, so if this is a curve, right? We're going to find out what the general equation for any circle is, and then find specific ones, like maybe what the equation of this specific circle would look like. Okay, and it all stems from this right here. Okay, this thing here, this D, is a distance that's associated with that right there, right? Well, instead of calling it D, let's call it R. Okay? Now, in our formulas, just for convenience sake, we don't like to have square roots. Guys, stop it. We don't like to have square roots. So how can I get rid of that square root?
Yeah.
How do you undo square roots?
Do that times 2 thing, or times by itself.
Times it by itself. Or timesing something by itself is the same as what power?
Multiplication.
you're going to square it. Okay? So I square the right-hand side. I square the left-hand side. And I get r squared is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay? Now, what we end up doing is ultimately that point right there is an x and a y. Okay? And I'm going to call this point here an h and a k. All right? Instead of using x1, y1, and x2, y2. Does that make sense to everybody? Okay? So my x2, I'm going to rewrite as x. And my x1, I'm going to rewrite as h. And then my y2, I'm going to rewrite as y. And my y1, I'm going to rewrite as k. That's just a notation thing. If you want to leave it as x1, y1, and x2, y2, you could, but you never see an equation of a circle written that way. They use this notation because when I say x1, y1, x2, y2, you don't know which one is the center. Okay, it's hard to decipher. When they use h and k, we know h and k are referring to the center. Does that make sense? Okay. And then the other one is x and y, and I don't need a subscript with it because I don't have any other x's and y's, right? So there's no need for that subscript to differentiate between another x and another y. And that thing right there, guys, is the general equation for any circle centered at h comma k. Okay? So that is like the y equals mx plus b. That's a general equation, right? That provides you all the infinite number of lines that we can come up with. That is the general equation there that you can come up with any circle. Now, and y equals mx plus b, or if I go y equals ax squared plus bx plus c, a parabola, there are things in there that don't change. Y equals mx plus b always has a y in it, right? Always has an x in it, right? Circles always have the y and x. Y equals ax squared plus bx plus c. They always have a y and x in them. Okay? When we're in the coordinate plane and we're trying to write an equation, we need that y and that x to be static. Okay? In every single equation that we come across. So those two things are always going to be x and y. H and k are the only things that change. Okay? So if I'm looking at the circle here, okay, and I want to write the equation of this circle, I'm going to write the equation of that circle.
Why does it do it all?
Just that went fast.
No subtract.
No. You already told me, that distance was 5, right? And that's your radius. So what is 5 squared? 25. Okay. Now, like I said, x is always going to be x. This minus sign is actually always a minus sign. And now what is h? Yeah. Okay. My ordered pair, it's alphabetical, right? hk. So the x coordinate is h for my center. So I'll write 3x minus 3. We'll square that. Plus then y minus what? 2, which is k. Okay. Now if I type that in, if I write 25 equals x minus 3 squared plus y minus 2 squared, it gives me that circle. Okay? And you see then that is then an equation that produces that. Does that make sense to everyone? Okay? What that means to us then is that every one of these points B, okay, if that's my x and that's my y, every time I plug that x right there into that variable, and I plug that y into that variable, and I evaluate the right-hand side, what's that right-hand side always going to work out to give me? If I plug in both variables on this side, what does this thing tell me that should equate to?
25.
Should equate to 25. Okay? So if I were to, let's see if we can show this real quick. The algebra on this side. If I take the, if I say x, the x of point B, okay, and then subtract from it 3, and then square that, okay? So right there, it's taking 5.59, the x value of B, so putting it right there, subtracting 3, and then squaring it. I'm then going to take the y value of B, so it's taking the negative 2.28, it's plugging it in right there. I will subtract 2 from it, and I will square that quantity. And when I hit enter, it should give me 25. And you see right here, it gave me 25, right? Okay. Now, when I go over here to that point there, now that formula is putting negative 1.64 in for right there. It's putting 3.87 right there. When it does that evaluation, does that number of 25 ever change? No. So every one of these blue points on that circle, we say satisfies the circular equation that we developed. Is that all right?
Yeah.
All right, and that's just like anything else that we've done. If I have the equation, if you guys have y equals, 2x plus 3, okay, any point on that line, okay, any point on that, if I take 2 times the x value of A and add to it 3, it should give me the y value of A. Does that make sense? No matter where I move that point now, is that 3.04 the same thing as y? 2x plus 3 equals y, right? Does that kind of make sense to everyone?
Yeah.
Okay. So all these points are points that satisfy that equation, y equals 2x plus 3. So the same thing happens in a circle. Same thing happens eventually when we talk about that thing. Every point on there is going to satisfy the equation y equals sine of x. And it's a practice that we go through all the time in algebra, but we learn the circle for the first time in this class. You'll talk about circles again in algebra 2. Ask some of your friends that are in algebra 2 right now. They're talking about things called conic sections. One of the main conic sections is a circle. Okay? And understanding a circle will tell you how to understand the ellipses as well. Let's see here. What's the distance formula come from?
You taught us it.
Yeah, I have.
You said you did.
Oh, you did?
It was like you taught us it. You're like, yeah, I have.
Huh.
That's what I was telling you.
If I have this segment here, that's A at x1, y1, and that is B at x2, y2. What does x2 minus x1 mean? x2 minus x1 means it's finding that distance for me, isn't it?
Yeah.
Okay. y2 minus y1 means it's finding that distance for me there, right?
Yeah.
So put those distances together. What kind of triangle is that?
Right.
A right triangle. So I'm going to know that distance. Let's say I call that distance A instead of x2 minus x1. Let's say I call this distance B instead of y2 minus y1. Okay? What could you say about A and B and how that relates to this distance out here, D?
And B.
Okay. Do that, right? So what is this?
Hypotenuse.
Okay, D is the hypotenuse.
Theorem. Pythagorean.
That's the Pythagorean theorem, right? Okay. So the distance formula is just the distance formula is just the what?
Pythagorean theorem.
It's just the Pythagorean theorem. And if a circle's equation is just the distance formula, but we squared both sides and did some rewriting of letters, I call it dr, I call it x2x, and I call it x1h, and that kind of stuff. Isn't the circle formula just the Pythagorean theorem as well? So we have 3 different looking formulas that all say the same thing. They all come back down to a squared plus b squared equals c squared. Okay? So if you ever get stuck at some point and confused with circles, you can always maybe go backwards and say, okay, what do I know about the Pythagorean theorem? And now what does that tell me about circles? Okay. If we look at, one of the goals or tasks of this section is to be provided with some components of a circle and then write the equation. Okay. Right now, every equation that we write is going to be of the format x minus h squared plus y minus k squared is equal to r squared. Okay. Now, h and k are that point right there. Okay. H is the x coordinate, k is the y coordinate. Okay. So if it's x minus 0 and y minus 0, we write that as x and y, right? Okay. You see the radius here is 3, correct? Do you see where that 3 turns into 9 right here? Because we square it. Does that make sense, everybody? Okay. Now, as I move my radius, change my radius, that goes to 4, so that squared 16, 25, so the radius was 5, becomes 36, so the radius was 6, and so forth. So hopefully that's kind of easy to recognize. So I can go back down to like a size of 4 here. If I look at the x distance, and I want to move this thing to the right, so I want to take my circle and move it to the right. Okay. If I move it to the right, let's see here. Let me just delete that. If I move it to the right, that became 2, 0 now, right? So this is now h, and that is now k, right? Is that okay with everybody? And you see how that relates it up here? X minus your h is 2. And then plus y minus k, k is 0, so we just y squared, right? And that is now the equation of this orange circle. Does that make sense, everybody? Okay. So what that tells me is that this minus sign is always a minus sign. It never changes. Okay? At least theoretically, it never changes. Or algebraically, the way we deal with it, it never changes. Because what happens when I do this? What happens when I move this thing that direction? Now h and k, h is negative 3, but what happened here? Yeah, but why? Exactly, because it's actually x minus, it's always a minus, but then negative 3. Okay, and minus and negative 3 becomes plus 3. Does that make sense to everybody? Okay. Again, that's a concept that you're going to talk about in Algebra 2 again, but maybe do it with parabolas. Okay. And then we'll come back to college algebra and do it again with parabolas and cubics and quartics and quintics and sine curves and cosine curves and logarithms and exponentials. Okay. So it's a very important concept to understand that if I'm moving it to the left, okay, it's actually going to look in my equation as addition. Okay. And if I move it to the right in my equation, it's going to look like subtraction. Okay. Now the same thing happens when I move it up and down. Okay. Let's say that I take that k value and move this thing up. Okay, so now we see that this is at h and that's at k. So x minus a negative 3 gives me that. And y minus 5 obviously gives me that. Does that make sense? So then every point that is so if I take that point right there, which has the order pair negative 1.4, comma 6.27, if I run that number as negative 1.45, I add 3 to it, take that number of 6.27, subtract 5 from it. Okay, so essentially taking 2.45 and what, 1.27, square those respectively, add them together, what am I going to get? 4. I'll get 4. Okay, every single point D on that red circle, at every one of these points, no matter what the ordered pair is, as long as it's on that circle, is going to make this equation true. Okay? So I want to do, in the next 5 minutes, I want to do a couple quick examples with you that you're going to see from your homework tonight, and then tomorrow we'll get into some that are a little bit more difficult. First one here is what is the standard equation of a circle with center is 5, -2, and radius 7? Don't worry too much about that word right there, that phrase. What I'm looking for you to write is x minus h squared plus y minus k squared is equal to r squared. We'll talk about some alternate forms that we can look at here in a little bit. But if that's h, that's k, right? That's what your center always is. Okay, and if you forget, it's alphabetical. X and y is alphabetical, h and k is alphabetical. Does that make sense? Okay. So now you're going to write what? X minus 5, and then y minus -2 equals 49. So what is this minus and -2 going to come? +2. And there's the equation of your circle. Okay. Now, if you're using TI-83 or 84, you can't graph that because those calculators, if I just open it up real quick for you, those calculators are set up to be what we call explicit graphers, okay? Because it's already solved for y, right? Okay, is my equation that we came up with for the circle solved for y right now? Is y isolated all by itself? No. So if you wanted to graph this in TI-83 or 84, you got to do some substantial work to get it in a format that you can graph it. Desmos, GeoGebra as well, are what we refer to as implicit graphers. Okay? Basically meaning the way you wrote it by hand, you can type that in. So I think we had what? X minus 5 squared plus y, is it +2? Squared equals 49. You can type that in, and it gives you that circle. And if I also plot maybe 5 comma -2, does that look like the center for that circle? Yeah, so I can maybe justify that I've done things correctly. Okay. Maybe you could use Desmos. I don't know if you can click on here. Yeah, you can click on here and see at those points that they gave you. They're just going to give you some key points. If I plug those in for these x's and y's, they will give me 49 when I do that. Okay. What about this second one here?
It's all right.
I'm going to write that. I'm going to write that.
Bottom notes is at
X
radical.
+2 squared, and then y +1 squared equals 2.
Radical 2.
That's h. That's k. This is your radius, but that right there has to be your radius squared, right? So radical 2 squared is just 2. All right. What if we look at this question here? Okay. It asks you to find the equation of the circle. So a lot of people are going to recognize that's your center, that's h, and that's k, right? So we can write maybe x minus 1 squared plus y minus k, which is -3. So y minus -3 squared is equal then to, we need our radius. How are we going to find our radius here? We're going to use the distance formula. How are we going to use, what points are going to use the distance formula between? That point there and that point there. Okay. What a lot of people want to do, because this would be easy, is they want to go from the center straight out to that point right there, right? And people are going to go 1, 2, 3, 4, 5. But if I zoom in, and it's problematic because of the numbers that you're using here, that grid line is right there. Does that make sense? Is the arc of the circle beyond that? So the radius is a little bit bigger than 5. Does that make sense? If you go through the distance formula, 2 minus 1 is 1. Square that, you get 1. Okay. 2 minus -3 is 5. Square that, you get 25, right? Is that radical 26?
Yeah.
Okay. So that is the radius of that thing there. Is that pretty close to radical 25?
Yeah.
Which that would be 5, right?
Yes.
Which would be counting over. So that would give me kind of the circle that would be just inside. Okay? So this is really the R that we're looking at, radical 26. So what do I get if I square that? 26. Let me type this in real quick. If we go, so this was what, 26 here. What did I say my center was? 1, -3?
I think so.
Okay. So there's 1, there's -3. Can I plot the point 2, 2? Does it show up on my circle?
Yeah.
Yeah. So that's justification then that working from the equation backwards, I get the picture that I started with, right? So it tells me I've got the right equation. Okay. If I were to graph my equation and 2 was not on there, then I know my equation does not model the circle that they're talking about. Okay. There's an assignment. I sent you an email. Last night's assignment is going to be, I extended it quite a few days to do Monday. All right. Today's assignment is open. It is also due Monday, but they're both due at 8:15. Don't come to me on Monday and say, I was playing on Wildcat time on Monday to finish this. I'm not opening it back up. You have tomorrow's Wildcat time, and you got all weekend. Okay?
Wait, so they're both on Math Excel?
Both on Math Excel.
Are they easy?